Okay, in this session or this class, we will be going over the STL concept standard template library in C++. So what I will be doing, I will be covering, I would say, specific types of STL classes, not all of them, but the most commonly used ones. So first we start with the stack. We will see that we have built-in classes, one for stack, one for queue, one for list, one for vector, and one for priority queue. Those are the ones we will be focusing on. Now, for each one of these, we will be having a set of functions that we can call. For the sake of the exam, those are the ones you're supposed to know. For every class, we have only specific operations you are required to know. For instance, the stack, we need to know the push, pop, top, empty, size. For the queue, these operations, and so on. So now, let's start and get the concept of STL. I prepared a project here that will do a demo for the STL classes that we need to know. First, what is STL? STL, basically, they are a set of built-in classes available in C++, and those classes will help us use advanced data structures. So we have seen that during the course we have been building data structures from scratch. We have learned how to do a stack in 2 different ways, how to do a queue in 2 different ways, how to do list in 3 different ways, and so on. Now, the STL is there for you in case you do not want to build your own data structure from the beginning, from scratch. You could always use those built-in classes. All what you have to do is to import or include the appropriate header class, the header file. There is a header file for stack, for queue, for list, and so on. And now you might ask yourself this question: what is the point then of doing a stack from scratch if I have a built-in one ready? And so is the case for the other types of classes. Like, we spend a lot of time studying how to build lists, doubly and singly linked lists, and so on. So why would I have to do that if I have something already built in? Well, we in the course learn how to build data structures from scratch. So first, improve our skills in building structures. Second, being able to customize those structures to fit our needs and our requirements. Third, sometimes those structures require a function that doesn't exist in those built-in classes, so you would need to do your own implementation and your own function. So there is a need for that, and sometimes you come up, you come into a case or a problem where none of the structures that is available built-in will help you. You have to even come up with a new data structure that is completely different than what we have studied. So in this case, those skills you are learning in this course will help you come up with new structures because you get used to building such structures. Now, just having this said, we still can use these built-in classes a lot. They're ready. We don't have to do any implementation from scratch. We just include and start using. So this could be very helpful in many cases. So let's start with the first one. Now, we know the concept. We know what stack is, queue is, list is. So we just need to do a demonstration, see how actually we can use these classes. This file that's available on our course, e-learning course, has the examples that I will be running. I'll be running different examples, and the description of the example, what exactly it does, is available there. So this is example 1, 2, and so on. So let's start with the first example. In the first example, what we have is we will demonstrate how we can use stack and queue. Now, as you can see, to use a stack, all what I have to do is just to say stack and specify the data type. So here I'm doing a stack of integer. I can do the same. I could do the stack float, stack 2, for instance. So this is all what I have to do to define a stack. I include the library for it, and then I start using this immediately. Now the thing is, the stack that is built in coming from STL is a bit different from what we studied before as implementation. So here, if I want to just show you the operations, if I do S2 dot, it will show the operations that are applicable on this object, which is the stack object. Remember, we are not required to know all of them. We need to know how to do pop, push, and check for empty status, and also know the size function. Usually those are helpful ones, besides the top function that you are familiar with. So here in this example, I define a stack, and also I define a queue in the same way. Now remember, a stack is the one that's last in, first out, and this is the one that's first in, first out. And as you could see, the C++, the Visual Studio IDE gives a color for built-in classes or classes that are recognized, so that it helps you know that this is already a class available in your system. Now, what we do in this example, we're looping through 0 through 9 values and pushing them into the stack. And accordingly, the value 9 will be the top of the stack. Then I will defining a queue. And notice that here we're looping through the stack values. I'm saying while my stack while not my stack is empty, I'm saying like as long as my stack has values, keep doing the following. Now, what is it I'm doing here? I am I define integer x, and this integer x, I will use it to basically get the values of the stack. Now notice here is a slight difference from what we studied in class, from the one that we built from scratch. The thing is, to be able to get the values of the stack, I cannot just use pop. Pop is a function that is void function. So for instance, if I just show you here s2.pop, you would see here that pop is a void function. What does it mean to say pop is a void function? It does not return any value, it just pops. So how can I know what's the top value in the stack? I have to use the top function. Now the top does not do pop though. Remember, this is different than what we studied in the course. We had top EL in the past. This is top. I will only return the top of the stack. So supposed to return the first value 9, and because the last one that was pushed was 9, so I'm getting the top, I'm popping it from the stack, I'm putting this back into the queue. So the first value that will get into the queue is 9, and then the next value is 8, 7, until we get to the last value, which is 0. So now I'm just demoing how you could use those. Notice this other difference, which is the queue doesn't use enqueue dequeue operations, it uses push operation. So the queue object, as you see, doesn't have enqueue and dequeue. It's similar to the stack. It has push and pop, but the meaning is different though. The meaning here, it's first in, first out, while the stack is last in, first out. So that's just maybe the basic difference between stack and queue, and how is it different between the built-in STL classes and the ones that we did from class. And here I'm doing in the second loop. That second loop just shows how I can basically grab the values inside the queue, just get the values from the queue. Now in the stack, I had the top operation, while here I have front operation. You have front and back. So if you look here, you have the back function, which gets you the last value, and the front function, which gets you the first value that was entered into the queue. So up to here, it's actually very straightforward. What we're doing is just showing you how you could use the stack and the queue. And as you could see here, so I had values pushed into the stack, then I removed them from the stack and put them inside the queue. And then I'm taking them from the queue and putting them back into the stack. So simply this what it does, it will reverse the values because I put them in the queue and then putting back into the stack will do the reverse effect. Now, and then finally, I'm just looping through these values and printing the values. So here, if I just let me remove all these examples, just show you one example only at a time. So if I run this example, we see now it's printing 0 through 9, and The reason for that, it's printing 0 through 9. Remember, there were 0 through 9, and then I put them in the queue. They were entered into the queue 9 through 0, and now so they are in the queue 9 through 0. Now I'm pushing them into the stack 9 through 0, so they will be back, 0 will be on the top. So now as I'm printing, 0 will be printed first. It's just a demo how actually we could use a stack and a queue in STL based. So all what you have to do, remember, is just stack with the data type. Remember, there is no stack T here. I'm not building my class. I am using already existing class. I am in the main function. So that's it for stack and queue. That's all what you need to know for how we could actually use a stack and queue. Let me move to the second example. The second example shows how we could use a special kind of queue called priority queue. And so let's just run this example and explain what it is. Now, the priority queue is different from the normal queue by one thing, which is it's not first in, first out. It's the one that gets out is actually the one that gets popped is the one that has the highest priority. So here in this example, what I'm doing is I'm defining a priority queue. Notice to define a priority queue, there is no class for priority queue, only queue will include it. Now, no header for the queue. The queue includes both queue and priority queue. So I'm defining a priority queue of type integer. I'm inserting 10 values randomly. So I'm as you could see, I'm doing x equal random mod 10, so I will have values in the range 0 through 9. So I will be putting some random values in the range 0 through 9 inside this priority queue. Now the thing is, I will be going through these values and printing them. So it's the same way as you are going through a queue, as you see here, while not empty, and it's not the back or front function. There is no back, front in priority queue. It's top because I'm only getting the top priority. And as you could see, I'm just doing the popping process, same way, and printing the value. So if I just demo this, you will see we are actually getting the values sorted 9, 8, 8, 7. Now why there is redundancy in values? Because remember, this was inserted randomly. Those are the random values that the system grabbed, the 10 values. But the way how it was printed, it printed 9 the top, 8 next, and then 8 next. Why did it print this order, although they were like random? For one reason. It printed them this order so that because I am using priority queue. I printed 9. 9 is the top priority. By default, it's the higher is the better. So here, maybe just to show you what actually is happening, I could just print the values as we are inserting them, so you could see what's actually happening. And let me just do that. Okay, so if I run this again, notice the values that were inserted initially are 174. This was the order of inserting, but the order of printing, it favored 9 over all other values because it's the highest priority. And then it favored 8 next, and then 8 next, and then 7, and that's all because simply it's a priority queue. If it was a normal queue, remember the first value was entered 1, so the first one will get out will be simply 1. Same thing, second one will be 7, and so on. Why did it get 9 as the first value? Because again, I'm using priority queue. So this is what it is for now. So that's the concept of priority queue. Again, how to use it? We just do priority queue, the data type, and then start pushing and popping. And to get the value of the top priority, we just call the top function. Just remember, there is no is empty here. It's empty. Is empty is the one that we use for the ones that we built from scratch. But the built-in ones, The STL ones, they use the empty function, and all is small case, as you can see in this example. So this is the second example. Now the third example demonstrates how we can simply use lists. So let's go through this third example. Now in the same way we have done like singly, doubly linked lists, array lists, there is built-in list that is part of STL. As long as you include the list function, you can start using it. So here I'm doing list of type integer. Notice they are all the same. Queue, stack, priority queue, list. They are defined in the same way. You just mention the class name and you follow it by the data type, and then you define your object variable. So you could use that. Now, as far as a list, notice this example, what actually it will do. It will do this, which is we'll loop through values 0 through 9, as we just have seen. And instead of add tail and add head, there is push back and push front. Push back is equivalent to add tail, and push front is equivalent to add head. So that is the main difference as far as how we can add. So this will actually insert the values 0 through 9. Each value will be inserted once in the end, the back, and one at the front, which is the head. So I just use push back, push front, and of course there will be pop back, pop front. So this is the difference between add head, add tail, delete head, delete tail. It will be push back, push front, pop back, pop front. So you need to get used to this. Now the thing is, how do I loop through a list? Remember, I'm using the list from outside. I do not know what are the details inside. So to be able to loop through a list, we use the concept of iterator. This is how we define an iterator. There are more than one type of iterator. This is the basic type iterator. You define a variable. It's like you're saying here, I'm just going to loop through a counter j. And then I'm saying here for j, I'm just going to show you so you maybe will understand it better this way. So here, let me correct this so you see it like very well. Okay. So now this is like saying I'm making a loop counter to be able to go through the values of the list. I inserted values here. So how can I go through them? I do for j equal the list that begin. It's like saying that head. And as long as I do not get to the end, keep going. Now notice how you print the value. You have to use the pointer sign. Now this one to be explained well, maybe I need to do like this simple demonstration. Just give me 1 second and I will prepare that. So let's just show by drawing what we have here for the list. Okay. So how is the list actually done in STL? When we say list, let's say I have the values 5, 7, 3, 8, and 9. Let's say you added values to this list. Now, the way you would need to see these is there is a pointer called begin that points at this. And you need to think of that the last value has a pointer that points to nothing. That is the 9. Will be pointing to this. This will be this next, this next, and this next. And of course I have the backward pointer. Now, this is the begin pointer, and this is called the end pointer. Notice why I did this drawing. So to show you that the end actually doesn't point to 9. It points to a null value after 9. So if I want to loop through all the values, I define this iterator, let's say j, and I say j equals begin. So when you say j equals begin, it will be coming here. Each time I do j++, it will start moving this way to the next node until it hits this last one. This last one is null. So I'm saying as long as I don't reach the end, keep printing. That's why it will be printing 5, 7, 3, 8, and 9. It will print 9 because 9 is not the end. The end is the value that is actually after 9. So this is how the list. Now pay attention that you could go backward. To go backward, there is this R begin. Sorry for that. And then there is this R end. What's the difference? R begin actually is 9. And R end is the value that is before 5. So this is, it's like, think there is a value here. This will be the R end. So if I want to move forward, I go begin to end. If I want to move backward, I go R begin and actually end on R end. That's one way how we could do it. Now to go backward, you have to define what's called reverse iterator. But remember, I have these 4 pointers, R begin, end, and R end. Each one has its own purpose. So just wanted to demonstrate how the list is structured. Now remember, J is a pointer. So if I want to print the value, we know from C++ I have to say star J. J points to the whole thing. If you want to just get the value inside it, you do star J. Okay, so that's what actually was happening in here. Is I have made, as you could see here, a loop. So we added those values, and then now I'm saying loop from the beginning to the end and start printing those values. Now those values will be whatever I actually pushed back in here. And then, and notice that the j will reach to the end. I could do j minus minus. J minus minus means move backward. When I start moving backward, what happens is I could just start traversing back the list from last value all the way to the end. And notice here I'm saying go all the way to the begin, not to R begin. And accordingly, this will not print the first value. So let's run this just to show you what actually is happening in here. So as you could see here, what we have in the first part, which is this one, we have added the values. Notice the first value will be added 0 at the back and then 0 at the front. And then when I is 1, it will be 1 and then 1. When 2, 2, 2 until it finished 9, 9. So this is how we get this first output. The first output will be coming from this statement, the first line. Now the second one will be going backward all the way from the end all the way up to 8. But the 9 was printed because I have an additional cout statement here. So if I remove that additional cout statement, you would see actually that the 9 will not be printed in the second time. Okay, so this is how we can actually loop through lists. It's we use iterators, and if, by the way, if I want to use the R begin and R end, all what I have to do is just simply define a list iterator of the second type, which is called reverse iterator. If I define reverse iterator, then I can simply make a loop. Let's just say k, and in this case I will do R begin up to R end, and this would be k. Sorry for that. Okay, so now let's just here, let's see k, and let's just say statement second output. So if I do print, so as you could see the second output, it printed them backward. Of course, maybe if I remove this line just to show, so we have one value instead of 2. So notice 0 through 9. Now the second one is doing it backward. That's how I did it. 9, 8, 7, and so on. Now, and also notice the reverse iterator, I still do k plus plus. Okay, while if I want to go backward on the normal iterator, I am doing j minus minus. Those are just things to pay attention to. So from this list thing, I mean, it's really very simple. All what you have to do is to define list, and you could use push back, push front, and we have mentioned also that we could always use the pop back and pop front. Here are the functions, pop back and pop front. And also you always have back and front. So back and front for head and tail, pop back for removing the head, pop front for removing pop back for removing the tail, pop front for removing the head. So I think it's very self-explained. It's not much, I mean, to know basically. So this is the third example, and let's move to the next example. Now the next example, honestly, is not much different. It's about what we call vectors. Now let's look at this example. For vectors, they look pretty much alike like a list. If you see here, I'm defining vector, of course, after including the list vector. I'm defining a vector of type integer, and I'm doing the pushback thing, which is the same as list. So I'm putting values inside it. And then I'm defining iterator. So there's not more, it's the same. It's just the iterators of type vector, not list. That's all. So I have the concept of begin, end, and all of that. So far it's exactly the same as a list. So what makes the vector different from the list? Now, the way we can loop through it, let's skip this for now. The beautiful thing about a vector is that you could do direct indexing. Same as array, as you could see here, my vector I. So what is this? This is simply, I'm saying loop through the vector from 0 through size, the size of it, less than size. And it's like I'm doing an array. I'm saying print my vector of I. So this value, so if I remove this for now, and just show you what exactly is happening, I'm just looping through the vector values and printing them. Here, I did it first using the iterator, and I did it next using the direct indexing approach. And it still gave me the same effect. It's the same effect. So it's just another way of how actually we can loop. This is a way where it's done via pointers. I mean, you don't have to basically worry about it. It's a pointer approach. It's a C++ thing. But make sure you know this approach and this approach. So this is the same. I mean, I'm doing push back, push front, and I could do pop back, pop front. Here's all the functions you could use. As you could see, I have back, front, and pop back, pop front, and this is basically how we could use that. I apologize, it's just pop back and push back. There is no front. The vector doesn't have push front. It's only push back and only pop back. That was for the list. I was saying it for the list. So now there's just one thing maybe worth to mention here is the vector can be initialized with a specific size. So I could say initially I want it to be of size 30. That is like saying I know ahead of time I have like the size I expect it to be around this size. So this way you are giving initialization value of the size. Now does that mean I'm only gonna go up to 30? No. Notice what I'll do. If I put 100, although initial size is 30, but it will grow the size. So if I run this, so just to show you, it immediately put values 0 through 99 without a problem. Although I made the size 30, but it grows the size automatically. I don't have to worry about this. That is the main difference from array, of course. Array will not do that for you. Okay, array will not do that for you. Of course, there is an initial size. If you don't put a size, there is an initial size that will be automatically initialized. I think it's 8 or 16. Doesn't matter. You don't have even to know it. But what you need to know, it will grow that automatically. So this is what vector is. So you have seen these are the classes, very simple, straightforward to use. Make sure you know how to use them. Of course, I was doing always integer, but it could be even of an object. It could be of a float, double, anything, any data type. So that's just to mention. Now the last example shows how we can use search and sort. Now, so if I continue the same example, which is the vector example, let me run this. It will show how you can do search and sort. So let's do that. First, to be able to do search and sort, you need to include the algorithm header. Now, so I think this is using the stack, so I must bring the stack, which was from previous examples as well. So let me get all the examples all together. This is available for you, so you guys could anytime download it. So going back to the sort, this is how you sort. Sort is very straightforward. You just give it the vector name and identify begin and end, and it will automatically do the sort for you. Now it will do it using order in login, using built-in sort available by the library. You don't have to worry about what function is that, how it does it. It's just you use it. You just say sort, it will sort it for you. Of course, sort doesn't work for queue and on those kinds of things. It works for basically vectors and for lists, but it will not work for the data structures that are not designed to be sorted. Okay. So this is the sort function. Now the search function is also kind of tricky. This is how we apply search. So here in this example, I am getting values from the stack and I want to put them in the vector, but I want to make sure that values are not going to be inserted twice. How do I do that? I check using find function. The find function is also built in. You tell it search through this vector from its beginning to its end, search for this value x. If this search process reaches the end pointer, it means that it doesn't exist, because remember, end means null, means nothing. So this function either returns end or it will find the value if it exists. If it exists, it will return a pointer to it. If it doesn't exist, it will return end. So here I'm saying, like, if it returns end, it means this x is not inside the vector, and accordingly I'm putting this inside the vector. So the find function, this is how actually we can simply use that. So this is just again a quick demo. I hope now the STL is clear for you. Make sure you study it well, because we always have a question about it in the exam. Thank you very much, guys.